Welcome Wildcats. Today we're going to be looking at the second part of section 1.2. We're going to be looking at a couple of more graphs. So today, instead of looking at the linear, absolute value, and rational graphs that we looked at yesterday, we're going to be taking a look at quadratic and square root graphs. Now, we are still going to be talking about a lot of the same things. So we're going to be looking at specific characteristics of these two graphs, just like we did yesterday. We're going to be looking at the domain and range, the x and y intercept, maximum number of roots, our zeros, our end behavior, and whether or not these graphs are continuous or discontinuous. So, like I said, we're going to go ahead and start with the quadratic functions. And just like all the previous ones, we're going to start by looking at the parent function of the graph. And in this case, that graph looks like this. Now, when we're looking at the quadratic parent function, or any quadratic function, you're always going to see this u. The only other possibility is it could be upside down, and you'll see an n instead. Now the important part is when you're looking at the parent function, we're just going to be looking at f of x equals x squared. So that's that U shape that you see on your screen now. The domain and range for the quadratic parent function, we can see that for our domain we go all the way out to negative infinity. It never stops going to the left, and it never stops going to the right. So our domain is negative infinity to infinity, or all real numbers. Our range, though, we see on the graph that we cross right here at the origin, 0.00, but our graph never goes below that. So since the graph never goes below that, starting from the bottom, we have our range starts at 0. However, we also see that it continues up continuously both directions, so it goes all the way up to infinity. The question we have to ask ourselves, though, is does it include that 0 or not? For this case, the answer is definitely yes. We can see that it physically touches that line there. So our domain, negative infinity to infinity, our range, 0 to infinity, with the bracket to indicate that it does include the 0. Now, since we are crossing right here at the origin, we know that we're touching the x-axis here and we're touching the y-axis here. So that means both our x and y intercepts are 0, 0. However, you will note because of the shape of the graph, if we were to drop this graph down a little bit, because of the shape, we'd be able to cross the x-axis in two different places. Since we can cross it in two different places sometimes, that means our maximum number of zeros is 2. Now looking at our end behavior for the parent function, we know that we just talked about how it continues going to the left, so as x approaches negative infinity, what's f of x doing here? Exactly, we're approaching infinity. Same thing happens to the right. As x approaches infinity, we can see that we're still going up, so f of x approaches infinity. Now when I'm drawing this graph, one of the things that we note is that I never have to pick up my pencil. Because of that, this graph is continuous. Now our next function that we're going to look at is the square root function. Basically the opposite of a quadratic. It looks like this. With the quadratic, we had our u, and with our square root function, basically it looks like we're just lying this over. So our square root function is just that line. You will notice, though, that the bottom does not exist. We'll get into more detail as to why that happens in later lessons, but just know that for our square root function, it's just this line that you see on your graph now. The equation for this is f of x equals square root of x. That funny little symbol, I'll call it a radical or the square root sign, we read it as square root. Now the domain and range for this graph is a little different than any of the ones that we've seen yet. We see that we cross the right here, so the furthest left that we go is 0, but it continues going on forever. So our domain is 0 to infinity. Now when we look at our range starting from the bottom, the lowest number that we have is 0, and it continues to go up infinitely long. So both our domain and our range are actually 0 to infinity, but we can see that it includes that 0. Because we're crossing at x and y, or sorry, at 0, 0 here, we know that our intercepts for this function, just like several of the previous, both are 0, 0. So x-intercept 0, 0, y-intercept 0, 0. Now with the shape of this graph, hopefully you guys can see that it's not possible to cross this line, our x-axis, more than once, which means our maximum number of zeros, or our maximum number of roots, is 1. Now, end behavior for this graph is a little different than we've seen before. So we notice that we're only coming from one side. As we go to the left, we're approaching 0 with x. And as we approach 0 from x, we're getting closer and closer to 0 for y. So the way this is written, as x approaches 0 from the positive side, f of x approaches 0 from the positive side. Our our right side end behavior, much easier. This continues on forever, so as x approaches infinity, we can see that it increases slowly, but it will continue going up forever. So, as x approaches infinity, f of x approaches infinity. And because I can draw this with my pencil and never pick it up, this graph is in fact continuous. That is all the information you need for the second part of the questions for section 1.2. I will link those in the description below so that you guys know which problems you should be able to do.